All right, let's dive nose first into one of our most mysterious senses, smell. For centuries, trying to map out the world of scent has been this just chaotic puzzle. But some new science is finally starting to reveal its true and, let me tell you, very strange shape. So let's get right to the heart of the mystery. What is the shape of smell? I mean, if I asked you to draw a map of every possible scent, what would you even draw? A straight line? Some kind of simple grid? Well, it turns out the answer is way weirder and honestly more beautiful than we ever could have imagined. I mean, think about our other senses for a second. Vision? That's easy, right? We've got the spectrum of light, red to violet. Hearing? We've got pitch, low to high. They're organized, they're predictable. But smell? Oh, smell has always been the wild west of our senses. Just this total jumble of perceptions with no clear map, no obvious way to organize it all. And all that chaos, well, it led us down a really long and, as it turns out, totally wrong path. For years, our attempts to chart the world of scent were just based on a complete misunderstanding of how it's structured. We were trying to use a map that was, fundamentally broken from the start. So, for the longest time, the idea was to try and fit all these smells into a nice, neat, simple grid. Like a piece of graph paper. The logic seemed sound, right? If two molecules looked similar on a chemical level, they should smell similar. But the data just would not cooperate. It just refused to fit. The map was always broken. So, the big question is, why did the map break? And it turns out the answer wasn't to try and build a better grid. Nope. It was realizing we were using the wrong kind of map entirely. The clues to the true shape of smell, they were hidden in the very chaos we'd been trying so hard to ignore. Okay, so scientists started digging in and they found three really critical clues. First off, our smell receptors, they don't respond in a simple on-off way. They fire in these broad, overlapping hierarchical patterns, kind of like the branches of a tree. The second clue, a tiny change in a molecule's structure can cause a massive leap in how we perceive it. I'm talking like from something that smells like pineapple to something that smells like sweaty socks. It's a huge jump. And third, the map is weirdly empty. Most of the smells that we could theoretically perceive, well, they just don't seem to exist out there. And this is where it gets really weird. Okay, on a normal map, the shortest distance between 2 points is a straight line, right? A to C is shorter than A to B to C. But in the world of smell, that rule gets broken all the time. It's as if you discovered that the direct flight from New York to LA was somehow longer than flying from New York to Chicago and then to LA. It makes no sense. And this totally bizarre property was the final nail in the coffin, the ultimate proof that the map of smell isn't flat. So, okay, let's recap. You've got this tree-like structure. You've got these sudden, massive jumps in perception. You've got all of these empty spaces. And you have these completely broken rules of distance. What do you do with all that? Well, all of these clues started pointing scientists toward a completely new shape for the world of scent. Which brings us to the big question, right? If the map of smell isn't flat, what shape is it? If we just toss out that old grid, what do we replace it with? What kind of geometry can possibly account for all this strangeness? The answer is a concept called hyperbolic space. And look, don't worry about the fancy name. The easiest way to picture it is this. Stop thinking about a flat sheet of paper. Instead, start imagining something that expands and branches outwards, like a piece of coral or the canopy of a huge sprawling tree. It's a type of space that just naturally has way more room, and it's perfectly built for this kind of complexity and branching. So yeah, this was our old assumption. A nice, flat, tidy grid where everything was supposed to fit neatly into a box. It was simple. Sure, but it was just plain wrong. The reality, well, it looks a whole lot more like this. A sprawling, branching, hyperbolic manifold. The shape, it just clicks. It perfectly explains why our receptor responses are tree-like. It explains why the distances are so weird. Because in this kind of space, taking what looks like a detour through another scent can actually be a shortcut. It all starts to make sense. Okay, so we've got our new map. That's a huge step. But a map isn't much good if you don't know how to read it or how to navigate it. So that brings us to the next big question. How are smells actually built from their component parts inside this new, strange geography? And this brings us to another powerful new idea with another fancy name, combinatorial scent mereology. But again, let's break it down. The key takeaway is this: we have to stop thinking of a smell as just a single dot on the map. A much better way to think about it is like a musical chord. It's a whole experience that's built from combining a bunch of different receptor parts, just like a chord is built from individual notes.
And this whole framework gives us this incredible new toolkit. It's almost like a kind of scent algebra. For example, we can use an operation called fusion to combine receptor signals. That's like building a new chord from individual notes. We can use fission to identify the shared signals between two different smells, like finding the common note in two different chords. And we can even use deletion to essentially remove a specific signal from the mix. For the very first time, we actually have a language to build and deconstruct smells with real precision.
Okay, and now we get to what is, for me, the most exciting part of all of this. Because this new map and this new language, they don't just help us describe the smells we already know. They actually point us towards smells that have never, ever existed before.
Remember that third clue we talked about, how the scent map is surprisingly empty? Well, this is where that becomes incredibly important. It turns out this huge, vast, hyperbolic space of possible smells is almost entirely empty space. All the scents that are produced by every single molecule in nature, and even all the ones we've cooked up in a lab, they occupy just a tiny, tiny fraction of the territory our noses are actually capable of perceiving.
I mean, the scale of this difference is just staggering. What this little equation is saying is that the number of real scents that we can create with a single molecule is just vastly, almost comically smaller than the number of possible scents our brains are actually wired to perceive.
And that is what we mean by an impossible scent. You'll also hear it called a fantasy odor. It's basically a location on this new map, a valid coordinate in our perceptual space that no single molecule can actually get to on its own.
So how do we get to these impossible places then? Well, if you can't send one molecule to do the job, you send a team. This is exactly what perfumers do when they build what's called an accord. It's a blend of several different molecules. Together, their combined signals kind of triangulate a position. They all point to that empty spot on the map, creating the perception of a smell that doesn't actually exist in any single bottle.
And the amazing thing is, you have almost certainly smelled these impossible odors, probably without even realizing it. Take Hyperion. It creates this incredibly airy, transparent, floral scent that has no direct equivalent in nature. Or Iso-E Super. That's the one that gives you that velvety, abstract, woody scent that's so hard to put your finger on. And then there's Cologne. That's the one that basically invented the whole sea breeze or aquatic perfume category back in the 90s. None of these are copies of anything. They are brand new creations, deliberate projections into those empty parts of the map.
So what this all boils down to is that the dark art of perfumery is really transforming into a new kind of science. We finally have a map to this vast, unseen world of smell, and we have a compass for how to navigate it. We can now actually pinpoint uncharted territories on that map, and then design the exact molecular chords we need to take us there.
I mean, this new understanding completely revolutionizes how we think about fragrance, about flavor, and about our sense of smell itself. And it leaves us with one really thrilling final question. Now that we have the map to this strange and beautiful universe, what impossible scent should we create next?